lab, kind of introduction to our redox reaction experiment. And there's a couple things just unique about this. This one is still using the same platform, but you're going to notice there's a couple different features that it has you use in order to kind of keep your time more efficient. It's going to have you use multiple workbenches within the lab. So there's a couple things just to read through, make sure that you're following through on those repeated reminders that I have. Whenever you read a step, read that step, then read the next step and the step after that before you do the step, just so you kind of keep perspective of where you're going. But also, like others, if we haven't gotten quite this far in lecture yet, this lab is all about electrochemistry. It's about oxidations, reductions. They're always happening together, kind of in reverse orders. And this experiment is going to allow you to set up multiple possible reactions. This metal with that metal, this metal with another metal, this metal with that metal. And it gives you all kinds of tables where you can keep track of whether or not a reaction occurs. The key, the umbrella idea for this whole thing is you're not necessarily, there's a couple places where you're measuring details, but the overall idea is you're just measuring whether or not a reaction occurs. Some people kind of ask, well, how do I know if a reaction occurs or not? And in the instructions, if you read carefully, it kind of tells you there are strong indicators of when a reaction is occurring. If you add two things together and a color changes, that's a good indicator that a reaction is occurring. If you add things together and there's a temperature change, like a radical temperature change, it's a good indication that there's a reaction. Bubbles appearing, solid appearing that didn't used to appear. The instructions kind of lay out what those hallmarks are that you're looking for, and really in terms of recording your data, you're just recording, for the most part, reaction, no reaction. But you have to set up all of these beakers and all of these things to get that information. At the end of the day, then we move past observation and we move into analysis. Okay, so what? You've got these big tables full of, these two metals reacted, those two metals didn't. The way you're going to analyze this is you're going to start to now use logic to figure out how strongly something is an oxidizer or a reducer. And the way you do that in basic terms is just, if you compared, hey, here's one metal that reacted with two other things, and here's a different metal that reacted with three other things. We're not talking about rocket science here when we start asking questions about which one would you say might be the stronger reactor or the weaker reactor if you have tables that kind of lay out all that data. And that's really what we're asking for in a lot of those follow-up questions and conclusion remarks. So the first part of the experiment is just follow all the steps and collect the data, fill up your tables. And then after your tables are full, the questions start asking you to rank things, come up with orders of strength. What is it going from weakest to strongest, strongest to weakest? We also ask, questions. Once you have things arranged, you'll be able to identify which are the oxidizers and which are the reducers. So again, if you need, kind of tune-ups on the ideas, check out your textbook. Get online and kind of watch maybe some preview videos for redox stuff. But otherwise, if you follow the directions and kind of fill up those tables, a lot of those questions kind of fall into place after that. So that's kind of it. That's the overview of what you're doing this week. So good luck, and we'll see you next time.